Gitlet. Okay. So let's think about this in a way such that you are making a repository, right? You are starting with Gitlet and then you're like working with GitHub and you essentially want to make a repository, right? There are a lot of working parts that essentially need to work with each other, obviously, right? But at the end of the day, what you have or what our goal is to essentially is to create a file system that will interact with each other. So there are a lot of things, like I want you to think on your computer, okay? Let's say if I'm working and on an assignment, right, and I want to create everything, and I want to, sorry, there's like a camera's like, me. Okay, so let's say, that's chill. So let's say on your fold, like you're working on an assignment, and you want to store all your files that you're working on. Let's say if I'm like writing a bunch of Microsoft documents into a folder. How would I do that? I'd first like start by initializing the folder. Right? And then I would put everything in there, in everything that I'm working with, like all the documents or whatever I'm doing into that folder. But at the end of the day, a folder, this isn't working, is a file, okay?
Yes.
And this is like a really, really crucial way to understand the visualization that was given on 61B. Like they have like this file thing or like this visualization that's really helpful. So, when I create a repository or any sense, I create this really big file, or like literally a folder, called working directory.
Okay, so let's say that like we have some sort of...
And your working directory will literally contain everything you are working with. So when I initialize this Git repository, it'll essentially, everything that's going in it, all the orchestrated instruments will be happening within this working directory. So I'm not going to get into the logistics of how to initialize the working directory or anything. You can see that your best friend will be utils. This class is your best friend. Some functions you should really think about when you're starting to initialize folders and files are .join. And .join is really important.
This is essentially like the lab that we were just doing.
Yeah, so like .join is really important. I think you might have done this in your Cappers lab, I'm not 100% sure. But .join is really great because like you can essentially link these files together. You can like, you know when you create a file on your like laptop, desktop, and then you drag a file into a folder? .join will do that for you. Like for example, putting this file of like this into this folder. This
it's only going to be like
is .join. Okay. So you have your working directory, right? And the next thing you kind of need to think about is your actual repository. Okay, like when you do Git in it, what happens? Everything comes up, a repository. So I'm gonna make another file here.
So let's say like
So the working directory is just a folder?
Yeah, it can just be a folder.
Okay.
Or again, folder is equal to file. So let's use the word file for now. You can do your repository.
Yeah.
Okay.
Does that make sense?
Okay? So your repository is essentially where all the magic happens, right? But there are three main things that I kind of want to stress when you make your repository. Also think about like your repository can literally be anything, but within code, I don't want to start thinking about code yet, but your repository will essentially be the main hub of where everything is happening, right? Where everything will be interacting with each other. So within your repository, you'll kind of have a couple of things. When we think about GitHub, what are the like main things that we might kind of think about, like in terms of like, or just like literally throw anything out. When you think of a repository, what do you kind of think of?
It's like adding and committing.
Adding, committing, yeah. What else?
So this isn't a branch.
Initializing. Anything else? Checking out.
Yeah.
Removing.
This is a commit.
Branches. Head. Master. all these crazy things are all happening in your repository. So literally, like, think about like your repository as like, if this marker wants to work, as like a circus.
We would have a branch.
And everything inside is like the magic of GitHub. Does that kind of make sense? Like, stop me at any point if this kind of does not make sense. Because I'm trying to speak very metaphorically right now, but like, I don't know if this totally like is going. Okay, so okay, the next thing to kind of think about, I want to start with like 3 stages here. Our 3 main things that we will categorize everything that's happening in this circus. You have your staging area. I really need a better word. You have your staging area. You have your commits. And you have this one more category. We'll just call it blob.
So wait, so the repository would be like another folder with
You want to more like
Gitlet
use it like why we use branches
that has staging area, commits, and blob in like folders?
It could be. I'm not trying to say it can because it's a very open-ended question. However you want to do this, you can. But if you're saying if that works, it technically can. Yeah. Well, I'm gonna grab another marker real fast. Give me a second.
Kind of like by the name of the commit branch.
Oh no, I don't think so.
Branches.
Stuff that is.
I think you guys are going to
Excuse me.
Oh, go ahead, yeah.
Okay, so you can also represent, at the end of the day, everything is going to be a file. So TLDR, yes, to your question, staging area, commits, and blobs can technically be files. But I also want you to know, in utils, you guys know the idea of serialization, right?
Yeah.
Serialization, I'm just going to do like a bowl of cereal.
Yeah, if I tell branch to go here and to clearly talk about
Serialization
branch, I will also.
is very important. I think before you start anything, really understanding the concept of serialization will literally make or break how you do Gitlet. But really understanding this, and everything serialization will be in utils. Okay? So serialization is essentially taking something and converting it to bits or bytes. And then you have the ability to take in anything, convert it to bytes, and then convert it back to its original state. So let's say if I'm working hypothetically for a GitHub repository, and I have this file or this code that I want to, what's it called, upload to my Git repository. What essentially I'll be doing is I'll be taking this code, I'll be serializing it. So I'm just going to do the serial to represent. And then this will essentially be uploaded to my repository through whatever. Like a lot of magic happens here. And then if I want to get this original file back, I could essentially go through serialization again, except I'm going to call it deserialized. I'm just going to do like an X through it. Does that kind of make sense? And I'll get my original thing. And this is equal to this. So you might be asking, yeah, do you have a question? Oh, because when I serialize everything, you know, then I'm going to upload it to my repository, right? Through like a commit, through blah, 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 right? So you might be asking me the question like, hey, like what's the point of like even, what's it called? Like, can't we just upload this code to a repository? Like, why does it need to be serialized? Well, let's say if I'm watching like a movie, I really like the movie Titanic, right? And I want to like upload it to my repository, but how am I going to upload things that are different now? I have like the idea of like code, I have the idea of movies, I want to upload everything. So when you serialize, it's really great because it's kind of a universal thing where you're able to essentially translate it into bytes and then put it into your repository and you can deserialize it. I also want to stress, you can serialize anything. Okay? And when you serialize things, you can put these serializations into your files. Okay. Does anyone have any questions up to this? Right? It's kind of like the skeleton and like the anatomy of things.
So we can serialize anything and put them into files?
Yeah.
So I'm not too sure. Like,
because at the end of the day, like we can't exactly store objects into files, right? That doesn't really. When you click on your like let's say if I'm working on like I see a 61B class. class and I have a folder for that. If I click on that, I just don't see like objects, right? I see files. And when I click on like my Gitlet project, then like it opens up and then there's objects inside those files. So I really want to stress everything.
Wait, let's pull up the spec right now. Just so I can look at it.
And like literally think about it in real life too, like when you open up the files on your computer. Does anyone have any other questions up to this point in terms of anatomy? Yeah.
How does like adding two serialized things work?
Sorry?
How does adding like two serialized things work? Like if you're trying to add both of them to the same file.
Like adding multiple serialized things? Like
Like say you have something, you serialize it, you have another thing you serialize it, and you want to put them in the same file.
yeah, so that is like the next step, which essentially is adding things,
Okay, so basically,
initializing
what
things,
this
committing
one does
things.
is that it changes
Okay.
at the point to the branch that it's given. That's
When
the
you
field
serialize
right?
things, okay, I also think like generally, like let's say if I want to serialize,
Check if we have other.
like let's say if I want to serialize a movie that I want to upload, right? I can do utils.join
So checkout's kind of weird.
whatever folder I'm
Basically,
working
like,
with, and then
this
that serialization, like or
These are
however I'm
changes to
storing
the
that.
file.
Does that kind of make sense?
Okay, so coming back
So,
here, what
when
this
I
checkout
have
command does is that now branch
Utils.join
points
will
to head.
essentially
Or head
take
points to
something
the
and put it in there, right?
Yeah.
But we can't just,
So-
the movie itself is a file, right?
In order to create
When we
new branches,
download the
we do
movie
something
from our
called, like,
computer, it's a
git
file. So the downloading part is a serialization. And the moving that serialized file into this folder is a utils.join. Does that kind of make sense?
So you move each one individually by joining it?
Yeah. Does that kind of make sense?
Yeah.
Okay, cool. So now I'm going to start kind of with the basics of what's going to be in our repository. So we have our staging area, we have our commits,
Yeah. So
and we have our blogs. Let's ignore this for now, even though
it's like head is like always pointing
let's
to
start
the
with commits.
right?
What's the first thing you do when you make a repository?
So
Anyone?
basically, like when you create a new branch, the branch
Since with I.
every branch always points.
Init,
Right,
yes.
it's just a reference
You
to a
essentially
commit,
do
right? That's
git
what a
init.
branch is.
And that
So
will
when you
essentially
create- when
bring
you do git
everything to
branch,
life.
all it's really
Right?
saying
Because
is
you
that
have your repository
I'm
that's
creating
set up.
another branch
So
with
when you do git
name,
init,
branch name,
you create
and
your
it's pointing
repository,
to the
and
commit
essentially what
node
will
that head is
happen,
pointing
there's a
to.
lot of things that happen.
That's what git
But like,
branch
for
is.
example, like I don't want to give too much away, but
Yeah. Yeah. So
what
like,
are
looking
some
at
things
this
that
example,
needs to happen when you make
like
an
when you master here,
init?
and then I
When you
create
do
a branch
init,
called cool beans. So now cool beans points
you initialize
to
things.
master because that's what head is pointing to.
So,
Right?
when you
They
do
just
init-
omitted head throughout.
Initialize. I'm not going to specify what. I'm
Yeah.
saying
I start
things.
pointing the cool beans after you create it.
So
You make your
when
first
I do
commit, right?
Yeah.
check out cool beans, now head is pointing to cool beans. That's what the star is.
Commit
And then
0.
now what happens
Okay,
is
so let's
like,
just
if I
start
make
with
a
that.
commit now,
We have our
now
first
what
commit.
happens is that cool beans.
I'm just going to
farther
represent
because we made
that
a
by a
commit with cool
box.
beans.
Okay?
but not match.
This is going to be commit number
Because now
0.
like head is pointing to cool
I
beans.
thought branch made like it made split.
And right now,
So
nothing
okay,
is in this
now
commit.
like what happens?
It is
if I
kind of
go
like our
back to
home
master,
base.
And I make a commit.
And once we
master,
have this, there's a
now
couple
we
of
have
things
a-
that also are initialized. Like, for example, we have our master
So,
pointing here, we have our
that's-
head
yeah, I think this
pointing
is
here.
better. I think that's
Right?
started
2 pointers are also initialized.
2 pointers. I hate the word pointer.
Oh.
Or like, because like, it's the right idea, but essentially whenever you use a pointer, I want the word pointer, think of it data structure.
Okay.
Okay? Because like a pointer is just like a metaphorical thing.
Yeah, yeah.
But how are we gonna actually represent that? A pointer
So like the working, when I was watching the video, like he made like a pointer folder.
is a data structure. And some lovely data structures that we can use are hash maps,
Oh,
Can I see your computer?
strings,
Can I use it?
which are the most basic ones, but also my favorites. Linked lists,
Yeah.
etc.
Okay, where do you store your?
Does that kind of make sense?
Okay,
To this point, does anyone have any questions?
basically, like, as we get into
So now where you have like we would have
this is like kind of similar to
a
like
linked list that
if I like go inside my doc,
it's the first element would be this, and its next
you guys
element
can
would
kind of
be
see
the
like
last commit,
we
or
store some.
You can literally use anything you want. Yeah, but like let's say now I actually want to start. You know, I'm watching the movie Titanic, and I really want to upload it. You know, so what's the first thing I do now? I probably gonna add things, right?
But basically,
Like I would add whatever, or actually, let's not use a movie Titanic. Let's say I'm literally working on Gitlet, okay? And I'm making all these changes to my code, right? And I want to essentially add it so that I'm not gonna lose my track, right? So what's gonna? I don't want to commit it yet
then we
though.
add it to the staging area.
Yes, we have our staging area. So let's just start with one thing.
so that's like how doc is.
And this is a stage for addition.
Inside.
Okay, so this can also be represented however you want. But essentially, before you make any commit, everything that you add will go into here. So let's say I am working on, you know, Gitlet. I'm just gonna do Gitlet dot right?
Yeah, you have to make the doc.
And so now I want to essentially commit this, right? Because now I'm ready to a point where I want to commit. But before you make any commit, you need to clear the staging area. Totally. Like there's no way. Also think about it this way. Have you guys ever tried to commit something? They'll be like, oh, first you need to, staging area is not cleared. You need to clear it before you commit. Right? So first you need to, so next thing I'm going to do is commit this. So I'm going to, this is going to be my commit number 0. I mean commit number 1. And what I'm going to do is I'm going to clear this. I'm going to put,
It creates a new commit first and then it clears it, or you say clear?
I think it happens like
Oh, at the
synchronous.
same time.
Yeah.
Okay.
Gitlet dot blah or one, right? Or Gitlet dot job. I'm just gonna call it Gitlet, okay? I'm gonna store it in this circle. But plus at the same time, okay, these pointer or these my head and my master, essentially they go up one, now they're up here. But the thing is, I can't just forget about this commit 0. What I have to because let's say if I realize that I'm failing Gitlet, dude, I just want to scrap everything, I want to go to the beginning. I need some way to essentially reference the first thing. So I'm just gonna represent that by an arrow. And again, I hate the word pointer, so whenever you hear the word pointer, think of a data structure.
Okay. So it would be like the first something that points. It's creating a new element in the data structure that can connect back to the things
Yeah,
before it.
and also, like you said before, I'm not trying to get too ahead, but some examples to kind of get your mind turning. This looks a lot like a linked list, right? What's up?
So you basically like multiple things to your staging area at one time.
Yeah, of course you
For
can.
example, if I were to add lab 11, lab 12, and lab 13, and then commit all of them at the same time.
Yeah, you can do that. That'll essentially, let's say lab 11, lab 12, lab 13. When I commit that, it'll essentially take everything here and move it to here. So I also want to keep, as we're talking about this, I know this is a lot, but some things that I want you guys to realize is that once I make a new commit, I need to essentially keep track of a couple things. My master and my head are going to move up one. My staging area for addition is going to be cleared. I'm going to have this method to get back, aka my commit 0 is still there. Yeah? So that is something. So now you're probably thinking, Gitlet. Remember, this is this code that I was talking about before. But then before I was ranting about how everything is a file, right?
Yeah.
So there's where the idea of blob comes in. Blob is a term that essentially means the content of something
Gitlet is a folder. That's
is
the
equal
folder we
to
use it. Doc Gitlet is a hidden folder that stores your Git information.
So your blobs are really awesome.
Yeah.
I hated blobs at first, but now I kind of really like blobs. But blobs will essentially contain what your something is. So for example, in this example, if I have code, my blob will essentially be the contents of my code. But again, I can't really represent.
It's like a hidden folder. Yeah,
I can't really represent the content of a code as a string or something like that. which is
Serialized.
serialization. Yes. So this is where serialization. This marker says. Is equal to your BFF. Okay? Because essentially, your content of Gitlet, so I'm just going to do content,
You can just create like hidden folders and there's like a top there.
is going to be here. So essentially, this
No.
will be referencing
He just likes to do that.
this.
Okay.
Okay? I also want you to keep in mind, let's say if I am continuing to work on Gitlet and I make another commit.
You're welcome.
Okay?
Yeah.
And I'm also working on Gitlet at this point. The content on my Gitlet is going to change. I'm just going to do Gitlet like or content. I'm just going to use content.
So
I
I
don't
do
know
this
why.
to do
So,
a case.
does this all happen
Yeah,
at the same
I don't know
time?
why
Like, as soon as you commit, it creates
Yeah.
an
I actually ran into the same problem. I don't know why that's the case.
It can, but it really is up to you.
Yeah, I
You
could've
can
figured
also like keep in mind in your working directories where all your files are. Like Gitlet
Yeah, I
is
could
going
have.
to exist.
I ran into the problem. I got annoyed and I couldn't fix it.
Okay.
Yeah.
Gitlet is gonna exist up there. You can do it before, you can do it after, but essentially, this block is the content of this. So this is going to point towards here. It would not be productive
like different
to just store the like Gitlet, like the name in here, because Gitlet is constantly changing.
Yeah.
Right?
Yeah.
Which is why where serialization comes in. It's genuinely your best friend. Okay. And then also one more thing. When I make commits, half the time it's like 2 a.m. and my names for commits are so bad. Like they're like cat, dog, I'm so tired, I'm so tired, I'm so tired, right?
Yeah.
So I don't think a productive way. Dude, because like
Important to have good commits.
yes, look at this guy. What's your name?
Okay, he's the last one.
I don't have good commits.
What's your name?
Pavan.
How do you spell that? You should look at
P-A-V-A-N.
P-A-V-A-N.
Don't go commits.
Important.
You should tell her what your commit messages are.
What's your commit message?
Yeah, what's your
Some examples.
what's your most used commit
Math
message?
7.
Yeah,
Homework
definitely.
7
Definitely,
That's the
huh?
tag.
So like that's a really profound quote. It's really important to have good commitment. Okay? So that being said, okay.
Yeah.
What else am I doing? Okay. So let's say if you're not him, you're not Pubin, right? You're not Pubin and you're like me, where all your commit messages are like, I'm so tired, I'm so tired, I'm so tired. Let's say if I'm working later, it's like in the morning, and I'm like, dude, everything I did was so bad last night, but I want to reference some sort of commit. And apparently the last commit that all the commits that I had 50 times in a row were I'm so tired. So which I'm so tired am I exactly looking for? Instead, but you're also me and you don't want to make better commit messages because like you're lazy, right? So the best way to kind of get to a commit is this thing called a SHA-1 address. A SHA-1 address is really awesome. GitHub essentially made this because they realized all the doofuses like me in the world, SHA-1 address is a very unique address. It's a very unique name such that it will never be replicated. The chances of GitHub replicating another SHA-1 address is so low, and if that happened, GitHub would literally fail, like it would blow up, okay? so essentially every single commit has a SHA-1 address.
Yes.
So instead of calling
My
it
goal
commit
is to
0,
blow get lit up.
or let's say for simplicity, I'm going to commit 0, but it doesn't have a SHA-1 address.
Get a replica.
SHA-1.0. SHA-1.2. I believe you can get SHA-1s in your utils file. So it's going to be up to you guys to kind of see how you want to represent your SHA-1s. You can represent your SHA-1s through literally anything. I don't want to answer that question, up to you, but I just want to throw out there that the names of your commits will be SHA-1 addresses. SHA-1 addresses will never be replicated. Okay, what's up?
What are like all the elements of a commit message? Like it has a SHA-1 address, it has a name, or like a text that you put in.
So you also have for example, a timestamp.
Yeah.
So these are something, I think there's literally instructions in the spec where you have to see that. There's also timestamps. for example, like in your commit, you may want to reference the content of that commit, right? Or the files that are in those commits, right? And the files of those commits are blobs.
Oh, so commits would be like folders with files and
Yeah. At the end of the day, everything will be a file. But whilst you're working on your code, this is the part where I'm gonna kind of transition into the actual code. Whilst even though like simplicity-wise, I've been saying everything is a file, but when you're actually coding, you're gonna have things like data structures, you're gonna have things like classes, etc., etc. So, however, I'm like saying this, you can literally represent your blobs, your commits, your staging areas as anything you want, but a good place to start are classes. And if you're really, really awesome, you can use data structures. You'll be using data structures anyways, but I would suggest starting with a couple classes. Don't use that many classes though, because the more classes you have, the more destructive it will become. Like don't use 10 classes, or I kind of did, but I don't know. But essentially, like a good place to start is your classes. So that's just an overall like how to get started sort of thing and some basic understanding. I hope that was helpful. But I'm gonna open up the stage, y'all. Do you have any questions? What's up?
For the blobs, do you only like add a new blob when you do git add? Or like how do you know what, like every time you change it, you only add like the new content if you add to git add? Or...
Yeah, so like think about it this way. When I make a commit, it's essentially removing everything from the staging area, or you're gonna also eventually realize that you need to do stage for removal. So I'm gonna quickly erase this real fast. Okay. You're gonna also realize that you're gonna have a removal thing. Because there's this one function called RM.
yeah.
I'm literally gonna write a skull next to it because I hate it so much. RM. We're gonna have to remove things, okay? But essentially, when you clear these staging areas, my thought process is that you're gonna take whatever's in here, aka the files, and then you're gonna essentially translate them to blobs, okay? Which is where you're serializing everything, you're kind of making it, and then you're gonna then put it into your commit. Okay? Does that kind of make sense? Because like it would be inefficient to make like a lot of blobs. Only make a blob when you are committing something, right? Because like I'll be working on my like code a lot, but it only makes sense to upload things when I'm ready to commit, right? Awesome. Does anyone, yeah, what's up?
So why do we need to have a master and a head arrow? Like, why can't we
Oh, that's a really good question. So there is a function called checkout.
So why do we need a master
And
and a
checkout, if
head?
you're someone like me, you use checkout a lot because you mess up on things like a lot, right? So the like point of checkout is essentially, let's say I'm working on my last commit and I realize like my Gitlet is so terrible that I want to like restart everything. I hope that never happens to you guys. But essentially, git checkout, and then you're gonna follow it by like some sort of like address. I want to say SHA-1, but I'm not 1,000% sure. I think it is SHA-1 if you actually use this. But you will essentially check out, as in you would, let's say my master and my header here, I will check out all the way. Let's say if I want to check out and I've added the SHA-1, it'll go here. So now my, I think it's head. My head pointer slash data structure will essentially be here. But my main branch is here. Think of it this way too. This is just a series of branches. There are also other times where I got my buddy working on some project, right? And he's also working on his own stuff. But there are times where we want to merge our branches together, which is when main will essentially move down, but like then like it just becomes a lot more complicated because you have like your your branches will essentially merge, and then let's say if I want to unmerge because I hate his code so much, that's when like head will move and stuff. So what I'm trying to say is you have head and master, but head can go back. But just because head goes back does not mean that master will go back. Master will essentially look at the main snapshot of where you want to be or where your code is. And just because I'm checking it, also say literally, like take the word checkout literally. You're just checking it out. You're not actually like going there and staying there. The going there and staying there is where master is.
So master's always on the newest one?
It doesn't necessarily have to be like that. let's say if I'm back at commit 0 and I'm like, dude, like I think this stage is much better than that. Then I can do, I think it's there's another command. I don't remember what it was. I think it's like something to do with branch, where I can move my master back here, if that makes sense.
But in a regular checkout, only the head will move to.
Yeah, in regular checkout, then your head just goes there, because you're checking it out.
Okay, I see.
Like anything in front of your master, do you leave? Let's say like you check out the first commit and you like that one, so you make that your master. Do you lose everything after the master?
I think it's somewhere still in the cloud, but it is very dangerous. I don't think you can get back to it, because I think what happens then, now that this is main, any new commits will be another branch. They'll start going here, if that makes sense. Don't be intimidated by anything in the spec that says dangerous. It's not literal, but it's like letting you know that like things will be lost. Like not in your code, but like for example, like that's when you like if you want to move your master branch, that's like what it means by like information will be lost. Yeah, what's up?
Why would you want to move your master branch if you have like a shell and ID for each one? Like what's the
So like let's say if I'm working on Gitlet and like this has literally happened to me where like I realize I'm like 1,000 commits and I'm like this is absolute like dog. Like I just want to like forget the pain and go back to my original one. That's when I would move my master and my head back to the original one because I just want to forget everything that I've done ahead.
But you could look through all the commits and then revert after.
Yeah, you could do that.
Oh, okay. So that would be like the checkout is just like looking at prior ones. It's not like it's not permanent until you do master to that one.
Yeah. But some word of advice is that like I think also if you use git checkout, which I'm sure you will during this project a lot, when you use git checkout, you won't be able to commit any code until your main and your head are at the same place again.
Main as in the master? Or?
Yeah, sorry.
Oh, okay. Can't commit until they're both in the same.
I believe so. Yeah, it'll give you like an error like, like it'll literally tell you like master and head master is detached from main.
Head detached.
Okay,
I remember that.
Yeah.
Yeah.
Do you guys have any more questions?
Both corners.
Was this helpful?
Yeah, that's very helpful. Thank you.
Okay, awesome. Send that video to me, by the way. I'm gonna post
Are you
it.
on it?
Do you record the whole thing?
Yeah.
Yeah, what's up?
Okay.
Have like a blog associated?
No.
When you initialize your
Well, it can if you want. It doesn't necessarily have to. Because when you initialize something, you're not adding any files. You only add files after your initial commit. I don't want you to think as your initial commit as commit 1. I want you to think it's commit 0. Because it's just like essentially starting the timestamp, it's starting all this, but you're not really, you're not, because your staging area is empty and removed. When you initialize anything, you're not moving any files to these two things at all.
What happens if you want to like revert to the version where there's like nothing?
Commit 0. Let's see. Oh, like that's like when you would be uploading the code and I believe what will happen is you'd either go to commit 0 or commit 1, like something like that. You'd have to check it out, but like, yeah. Does that make sense? Kind of. Are there any more questions? I think this is a really good area to kind of pause and you guys can like really marinate this in your head. Understanding this part or understanding the code will take you 70% there. If you don't understand it, then it's gonna be really, really hard. And trust me, like it's like I experienced it where I didn't understand the code, but some things to really, utils is genuinely your best friend. Utils is genuinely your best friend. Everything is a file, is also your best friend. Everything is a file, as in like, for example, like, I want you to think about like when you are in your computer, right, and you're working on a Microsoft document or something, or actually no, like you're working on a Microsoft document, what do? Like you do export to PDF, and then it will download, and that's essentially it converting it to a file. And then you will drag that into some sort of folder called like CS61B class. So that's what I mean, everything is a file. Like for example, when you're working on CS61B stuff, and you want to open a project, you just don't you don't click on your CS61 repo and you find objects there, right? You find files and projects, and then you open up the files and you deserialize them, and then you find your objects and your classes and your code. So essentially, the way that I was kind of explaining this is that everything will be a file, and you can serialize and deserialize things to obtain classes and objects and stuff. Here, I'll give you another example. Let's say I'm watching a movie online, like Minions or something, and I really like Minions, so I want to download Minions. So the conversion of watching Minions to downloading it is essentially serializing it. Remember we did serialization in cappers? So serializing it.
Changing it to bits of it.
Yeah. So then now I have a file, and then I will essentially drag that file into my movies folder.
Yeah.
So that because I can't just put the Minions movie in there. I need to convert it to a file before I do that. So that's what I mean by everything is a file. Does that make sense, everybody?
Yeah.
Thank you.
It's
Thank
a lot,
you.
but yeah.
And to put into folders, it's just join.
Yeah, to put it, join is your best friend.
So join to put it into a folder. Okay.
So join and YouTube are your best friends.
Thank you.